Today we're talking about moment and simple connections and how it is a great program for speeding up your design of connections. Moment and simple connections is available as either an integrated product into one of our packages, such as the building design suite, where we can see we have our connections from our frame analysis going through. If we move through again, we also then have, here we go, the power pad system. It also has connections integrated into the system. So if you are a small user, if you have a small practice, or if you don't get into big work, the power pad connections will do the job for you. We also then have the portal and the portal plus, and they can do connections straight into your portal frames, your single, your multi-bay portal frames. And if none of those suit you, you can just take the connections on its own and just use that. Nothing else, nothing more, just the connections. And the other lovely thing is that we have two connections programs. One for doing your moment connections, your portalized eaves and apexes, your multi-story rigid frames, your wind bases, your beam and column splices. All of those are available as part of the moment connection. But don't just take my word for it. If we have a quick look at what the software can do, the quickest way to find that out is come down and have a wee look in here. So let's forget about all that. So we can see our moment connections will do all your eaves and apex. It'll also do your multi-story. You then have your stiffened and non-stiffened base plates, hollow sections, eye sections, the apex we mentioned earlier. You then have your three different splices for hollow sections, columns and beams, which are optimized differently and are very, very efficient. And then you have the more interesting beam over and beam under connections, and these can be either shop welded or bolted. Likewise, your eaves connections can also be shop welded or bolted. Some fabricators now bring in what I call Christmas trees of columns with little stubs welded onto them, and then bolt about a meter out on a simply supported or splice to get a more rigid frame. That will allow you to do that. So that's your moment connections. The simple connections then gives you all, just zoom up a wee bit, your beam to column and your beam to beam, flexible end plates, your angle cleats. Very clunky and unpopular these days, but there's no welding. It's a purely mechanical connection, so some people like them. And then you have your fin plates, and you'll notice the notching and things like that on your fin plates. We then come into the bracing connections, which is also part of this simple connections environment, and you will see you have bracing to columns with beams or without beams, bracings to column bases, so it's attached to the base, vertical bracing and horizontal beam bracing, so all the standard bracing configurations with angles, with hollow sections, with flats, with channels, all considered. And the nice thing is, when we do the bracing to a vertical beam, we can actually elect, and you'll see this, to make this into a truss connection where there's only bolting on it, particularly for angles and things like that. So what I'm going to do now is I'm going to start the master series, and we're going to do some joints to show you how quickly, because it did say quick, how quickly we can create connections and optimize them. So coming in, I'm going to start master series. It's the 1st of September edition from 2 days ago. And here we come into our front screen of the master series. I'm not going to go through that in detail. We can come along and say that we want to do a standalone connection. If we want to do a connection inside frames, we'll go into the frame and then into the connections, and we'll see that in a wee while. But first of all, standalone connections. We've seen the different types of connections we can do. We've seen the massive arrangement of different connections. I just open this existing file and you'll see your eaves connections. You will then see, as we move down through the briefs, your extended end plates, your valley, but it's not really a valley, it's just an internal where you have a rising and falling rafter coming in together and it's aligned. So I suppose technically it's a valley, other than this is the wrong angle. I'm not going to go through all of these because that's going to get very boring. What I'm going to do is come up and start a brand new file connection. So let's go in and add a connection. So what we want not a simple, we want a moment connection. And we're going to use our preprocessor, our template library, and we're going to ask for an eaves type connection. And I want it to be haunched, so there's a haunched eaves connection. If I wanted to extend it, I could say extended. Obviously the person who created this didn't put the word haunched associated with extended as well. Otherwise we should have those two. But I'm just going to go for a standard haunch connection. Choose that. In it comes. That's my default. Now let's play around. First of all, let's look at the forces in the rafter. Moments 450, I'm going to make that 525. The shear is 300, I'm going to make that 400. And the axial of 100 is going to be 75. The end of haunch moment will be 350, so the moment out here. And yes, we will print it. So now let's look at our section sizes. If we just click on the column, we can see it's a 686 in S355, and we're happy with that. If I click on the rafter, we'll see it's a 533191 67. I'm going to change that section from a 67 to a 74, and it's now just updated that, and the haunch will also update because we have told it to make the haunch as the same section. At the minute, the overall haunch length is 2.5 meters. I'm going to say 3 meters. We're going to go for the 900 deep. So that's my basic geometry setup, and what I'm now seeing is a blue screen and some little red bits. But what I have just noticed is that I'm working to the old code because this file I was working with was an old file. So I'm going to change it to Eurocode and UK National Annex. So that's no fun. I'm going to go down to my bolts and see what happens when I take out a row of bolts and a row of bolts. So we can see now that we're getting our failure. We're getting two failures, moment capacity and shear capacity. The MasterSeries moment and simple connections work on the codified methods, so it's using the methods set out in both the codes and the SCI publications for designing connections. So for a moment eaves connection, you're looking at the weakest component returning what the moment capacity is. So we can see we're 109% overstressed in moment capacity. And I can solve that by adding in maybe another row of bolts. So another row of bolts at 90. And now we're down to 18%. And it is actually taking that row of bolts as well and trying to use it. So if I put another row of bolts at 90, we will now see that it's no longer a problem. And strangely, or logically, the shear capacity is no longer a problem because these two sets of bolts are available for shear now and not trying to resist the tension, the moment in the connection. Everything else was coming in as standard because it was set up as a template to have these in as standard. And if I go to my main stiffeners, I'm going to take out the bottom stiffener, put a 0 in there. End haunch, I'm going to take out and put a 0 in there. And suddenly we got an alarm bell. And one of the reasons for that is in the Eurocode there is a ratio calculation between the grades and thicknesses of the end of the haunch bearing for the flanges and the webs. So if we look down, we should see down here in the detailed, very detailed calculations that we're looking at a effective breadth over the breadth of the haunch for the yield against the ultimate of the haunch is telling us that we need a compression stiffener. Now if we put a different section dimension in, we will probably get away with that, but in my case I'm going to pop in an end stiffener. And that's how simple that wee connection is to do. Now it's putting in a default 12mm, and you'll notice I can actually click on the graphics to take me to all these editing pages, which is great. So I just want to go to haunch length, and I can change that, but in this case end of haunch weld, and I'm going to say make this a 6mm weld, and it's saying no, it's not high enough. We're going to make it an 8mm. Let's tie a 10mm. No good, so it does need a 12mm weld, end of haunch. The other great thing is if we were in very heavily loaded connections, we can ask it to not just do the welds, but to do a deep penetration. So rather than, if we need a bigger weld, rather than going up to a 10 or a 12 that may need several runs of your welding rods and it'll be a lot more expensive, we can turn around and say no, let's put in a 2mm of deep penetration, so 8mm weld with 2mm deep penetration. So what it's doing is it's assuming that this welds right through, and we actually end up with a bulbed weld fusion plane, and we then have the deeper fillet weld. It's in both the BS and the Eurocode, so it's a very, very useful tool to have. Obviously you need to have proper arc welding to do that. Now the software is very intelligent, because as well as telling you when the connection fails, it tells you when you're getting silly. So if I was to go and move that bolt up and change it from 80 to 50, sorry, 5 is a wee bit silly, 50 Tommy, it's going to tell you that we have a problem with this bolt. It's going to clash. So let's try it at 60, and it's just about making it, and go for 70, and it's now happy. If I went back to 60, it's telling you we've got a blue background, and while it's no longer clashing with the flange, it's telling you from the blue background that we have something wrong. It's got a big X. So if we go to the DIMS failure, we will see that the bolt clashes with the weld bolt clash. Change your vertical centers. So it's looking after you and making sure that you build connections that you can construct, and likewise with the other bolts as well. If two bolts were too close together, it would warn you. Obviously it'll also do your 2.5D and 1.4D and things like that for edge distances, so it's doing all those checks for you. But no eaves connection only has positive moment. So let's look at our forces, and I am going to ask under cases, there's no more cases, let's add in a second case, and we'll make this be -350 and minus 175 and axial detrimental minus 75 with end of haunch will be minus 50. And yeah, we'll print that one as yes. So it's saying it's okay. Okay, let's increase this axial to minus 175, and still in reversal we are okay. So these two bolts are actually enough to work that. So if I went minus 450, now we can see that we're getting the bolts not working, and it's the moment capacity, so we would need to put that extra bolt down there to make that work, or even there if you wanted to, but it's very inefficient down there. So we'll just go and we'll add in a row of bolts at, say, again 90, and everything now is happy. So we can do multiple loading cases. We can very easily add in more joints. We can very easily say, right, let's do a base plate, and let's do a circular base plate on a CHS with pitch circle diameter bolts. So no messing around, set it all up for you with the standard 6 bolts that you should have on a pitch circle diameter, at least in my thinking. So axial, I'm going to say I'm going to put a moment of 25, and now we've got a little problem with the plate thickness. So all we need to do is run along and say, let's make the plate 25, and now that connection would work. And it is working with all the bolts in compression. If we had a higher moment, it may work with some of the bolts in tension, and we would then have pull out. But I'm just going to do that on a more conventional asymmetrical base. So here we go, and we can see now that we're using the effective area methods, very, very efficient usage of the compression zone, and the forces are nothing big. I'm going to up that to 150, and we can see the area increasing, but we're still not getting a tension zone, so that's trying to move out. And if I make that 175, it's now moving away, but it's still got enough room to spread and get the compression at once. 225, and we should now end up with a tensile force here, and we should also end up with a bending here. So the plate bending is now problematic on that edge, and that's because we're taking not this as being the weak cantilever, but in fact this out here, which makes our life a lot more difficult. So base plate is 300. If I put in 40, so it was 30, 40, it's getting there, but it's not quite there. It's suggesting 43 mil. Now another way of solving that might be just to spread it out over a slightly wider. So if I made the base plate 600, then it's getting there, but it's not quite the same. And we could make that a bit wider and give us a different yield line. But in reality, what we've got to do is either put up the grade of the plate or go for a thicker slab base plate. 50 mil, easier than getting 355 base plate, and that's that done. As you will also see, we are looking at tensile areas, so we can see our plate tensile, our pull-out cones, and we're working on our shear cones. Now shear cones, always very interesting. Shear cones are an old-fashioned methodology, and they're really used when we have no top steel. So I'm going to say I want to use a punching shear perimeter, and it's still working on cones, and that's because there is no top steel. So I put in 10s at 200, And now we look at the stronger, more efficient punching perimeters. So that is the usage of the software in standalone mode. And you can design all of the connections with multiple loading cases using this. And even for your foundations, for your base plates, when you look at your forces, you can even set up whether or not it's a fire case and use the altered load factors and stresses for fire loading, which is very interesting. Now, let us step back and think about the software in integrated fashion. It's not a different program, it's the same program, so you don't need to buy it twice. So let us look at our joints example frame. So it's one I came across this morning. I thought, oh, that looks nice. It's big, but it's not too big. And here we go. It's a wee bit of a strange arrangement around here, but that's what the client or the engineers decided on. So let's turn on some pretty pictures and let's put some colors on it. I always think that works well. So a lot of portalized rafters, some not valley but apexed eaveses, so double-sided joints, bracing, mezzanine floors, the whole lot. And now what I'm going to do is, before I go into design, I'm going to look, yes we are in Eurocode, at something called design groups. When you're doing a frame, you don't want to design the first eaves and then the second eaves and the third eaves. So what I'm going to do, take this down just out of 3D. I'm going to take all of these and put them into the one design group. So all of these rafters are supposedly in the one design group. And then the second one is all of these bases will be in the one design group. Very, very useful. And my third group I've created. Oh, actually I did ridge, didn't I? Yes, I did. I did the ridges as well. And there should be, yes, I didn't give it a name. This is the mezzanine beam to beam connections, as you'll see. So we'll look after all of those. And now we'll go back now into our design. So we've created these groups. So into the connection design. And here we go, our first joint. And it's showing up all of these as being the same. And all these green ones are all the same connection. Now, what we also see is that the matching connections in the group are all these. And when we look at loading cases, there were about 30 loading cases, though all of them aren't ultimate. You'll see that you get cases going up to 30 or 20 in fact before you get to serviceabilities, and then back. So that's the next connection. So it's taking all the loading cases from all 5 of these joints, or the ones on the other side and everything, and putting them all in, pushing them all into that one group and checking them. So what I can do is I can now scan this for failures. And the only thing it will find as a failure is a couple of the connections I thought were compatible. It will tell me that they're not compatible. And I said file rather than brief, so it's doing them for all the joints, which is more fun than I need. And it's probably spoilt some of my thunder. Okay, so there was no design failures in any of the joints we've designed. So let's get back to that first brief. So all loading cases showed everything passed. And that's the beauty about linked design into the frame analysis. Because if you're dealing with a portal frame or any rigid sort of frame and you're dealing with sway stability, eaves moving that way is going to relax the joint. Eaves moving this way is going to harden up the joint, so the two moments will be ever so slightly different. So the different directions will give you ever so slightly different values. The other thing to understand is that the forces are always coming from the column rafter interface. So it's not the value here in our stick frame analysis, but the values that are in this part here, just here. So there we go. Now, our second design, let us have a look, and we'll just go and find it. There it is the base plate. And again, we can see all of these members are all being checked at the same time. So I am going to scan this brief for failures. It's going to walk through all the different designs, and it's actually just stopping on the fact that in the failures that one of the members didn't actually comply with the design. So that's not important. We just need to design that one separately. If we take this and scroll out, we should see one of them. There it is, the yellow one. This has got forces shear in both directions. It's got shear from the bracing as well as the shear from the other. So if I go and I add in another joint and I just do a simple external base plate and apply it down here, you'll see that it applies to this one but not those other ones because of the doubling up and the shear being added in different directions onto it. So very straightforward, very interesting design. If we want to then look at this one, we'll see all of those were all designed the same, all these three different designs. And not only does it design them, it always tells you which ones have also been designed. So it's at node 106 and 107, but more accurately on H to J, and it's giving you the ID. So because we haven't got grid lines everywhere, it's giving us subgrid lines. Again, very, very useful and flexible on the software design. So it is such a simple, beautiful program. Now we've got some more interesting items. We've got a bracing connection, which is coming in with PFCs and circular hull sections and circular hull sections. So obviously that's clashing at the minute and there's a bit of a log jam. So maybe we should spread this out a wee bit. So if we take this bottom and we bracing set out, and we're going to offset it by hopefully minus 100 is downwards. Yes, it is. Take this one and we're going to offset this. Don't know why it's got a horizontal offset by default. Just take that out. See what that does. Oh, I need a 0 in there. And that's better, but we'll just move it up by 100. And move away. And we'll now see the connection is coming and it's working. Now let's look at the connection because it's quite complicated. We've got a CHS and a PFC. The PFC is just sitting flat and flush. It's just bolted onto the gusset. The CHSs are working embedded into the hollow section, and then with a capping plate. So if I take this, I can see it's gone for an embedded plate. We have the scope to say no, I don't want an embedded plate. I want a L plate, which is a horrible design, cheap, but it gives you offsets and eccentricities which will cause it to give you a more onerous design down here. So if we look at the middle, we will see that it is taking into account the offset, and we're also taking into account the compression design on the gusset and on the angle cleat and everything. So it's very, very detailed design on it. It's looking at the buckling of both the plate and the gusset all the time. Now the T, as I say, is better than the L. The L does work in this case, but you're going to get a far better result with a T. The T gives you a more symmetrical loading on the member. If I was to come along and move over to say here, and I wanted to just add a brief, and I wanted to do the bottom brace, I'm going to say bracing, vertical bracing to column, and it's just a simple K-brace flats, and I'm going to say it's actually that one, so it's only one member coming in. Now it's giving you the very cheap and cheerful nasty square lug, but we can then have fun and say no, it's not square, it's a knuckle, wee bit better. My favorite is the straight, and if you want to get very flashy, you can go for the tapered. Looks lovely, but obviously there's a wee bit more fabrication to it. And as anybody will tell you, these aren't that difficult to do, because that one usually has an exact opposite in the far end. So the angle here is the angle over there, so there shouldn't be any wastage. We also have a couple more unusual ones. The triangle can be useful when you need extra weld, but I don't like it. I think it's a big waste of material, as we had it initially, the square. Now these are all set out by default. Brace clearance, which is going to be here to here. You're going to have your end bolt distance. You're going to have your perpendicular to brace, which means it's this distance. I think as aesthetically, I don't like them being right flush. It also, from a design point of view, doesn't really tell you where the plate stops. So I always like to see them at least 5 or 10 mil proud, so that you know it's there. It also will help with the length of the welding, which can also solve problems. So you have full scope over that. Now, even if we went back to something like a knuckle, which is a complicated 1, 2, 3, 4 sides. If we turned off the auto, you can come in and set out all the distances. What you're setting out are all of the notches. You're talking about a notch here out of the plate and a notch here out of the plate, and you can work out those notches. So top left has a 126 by 98, so that's the 126, and this will be the 98. And then you have bottom left takes a notch and it's all the way down to 0. So you have those available to you if you want, but unless you're trying to improve an existing thing, I would prefer to stay with the default values. Now, that is great and fantastic. What we also can do is your roof bracing. So there's your main member running through, your rafter running up, and then on both sides we have CHSs of different sizes coming in. Now, one of the things we can even do is, in general, is we can actually, for some of the connections, split them. And we can see this arrangement is not giving you the option to split. I think only when you have two coming in left and right rather than left and middle will it give you that option to split. But it's all there. It's all very, very powerful and very functional for you in the connection design. I don't think I've really left anything out other than I don't have any flats in here. I don't know what are those sections. I'm just going to ask for some section sizes. There's some flats. So if I went to do some connections on flats, I could come along and just turn that off. Well, I'll leave the section sizes on, doesn't matter. Create a new joint, vertical bracing to beam, and not a truss as I was saying with the bolting, but it's not a beam, it's a column, Tommy. K flats. And there we go, a flat. And again, you can just turn that around and get it into the system in the tapered or straight fashion. Reapplying that to a different end, it comes out and it finds the beams going in other sides, and it assumes that this is going to connect onto the beam because of the dimensions. It's more logical to connect onto the beam, and we can take that and say it's only connected to the beam. So again, we can take it such that we're actually just connecting it there, and obviously square wouldn't make sense. Knuckle is quite good, and that's going to give you a nice flow, particularly on this, or it down there, and the height. But you know, we would probably get away with a lovely straight as well, and everything will be good. So we have that scope and power to do all these different types of connections. Now, I don't think I've really missed anything out. One of the things I do from time to time I find lovely is doing a beam splice and moment connection. Going to go for a beam splice, and I'm going to go for countersunk bolts, and then we'll show you how to create your own database. So I'm going to go for countersunk external, and it's going to say where, and I think I need to get my members off, and I'm going to just put this into the top window. So I'm going to say I want it to be on this member, and it is 24 meters. It's a heck of a span for a single rafter. I'm going to put it at 12 meters along. So that's my default. Obviously it's failing, obviously. So what are we failing on? Well, we just don't have enough in there. So let's go to the web and let's increase that to 350. And then let's just put in another row of bolts, and that's done. All sorted and done. And we'll just scan that for all of the loading cases, and it's just going to check all loading cases, and there's no problems there. Now, another beautiful tool that we have, and this comes into play very much in the likes of the eaves, is the ability for the software to do the design for you. So what I can ask it to do is to come along and empty out most of the trash. So it's just got the basics, 1 row of bolts, and in this case a compression stiffener. I'm going to take that one out, put that to 0. And now what I'm going to ask to do is auto size this, and it's going to work 90 centers, 10mm plates initially, and off it goes. and it's going to size up and see that it needs that end stiffener, and it's going to look through all the loading cases and come back with the correct number of bolts. And bear in mind, it's an interesting result. Only run row bolts. What loading case is that? Let me see. Cases. Case 3, I would have thought would have given you. Well, obviously, with our loading, we seem to have a lot less loading than we thought on this side of the frame. We were previously dealing with the other side, and everything was working fine. So in this case, it's perfectly good, and it's going to work at that. But once you've got that done, then you can set it to add more rows of bolts just to make it look correct. You'll notice that all the dimensions are coming through, all the haunching lengths and everything from the analysis, from the master frame, from the master port, from the power pad. They're all the same. Now, let's say that we want to take a very naked basic connection. So what we're going to do is we're going to play around with this. We're going to take off that stiffener. That's not important. We're going to drop the forces down to next to nothing. Doesn't like to have no force. We're going to put a moment of 1 and 1 and 1 or 10. What I'm then going to do is going to say is print the case. I am going to take the weld and push that all the way down to a 6. Or in fact, if I leave it as 0, it'll put in default weld sizes. But I actually think 6 is a better starter. Doesn't matter about anything else. I now want to save that as a template. Noticing that we're also working in 275 grades. So, if I go to Options, no good. Utilities, Save Joint as Template. So it's going to be called Tommy Demo. And the tag is going to be haunched. Add the tag. And we could put something else if we wanted to, but there's nothing else we need. Now for the real fun and games, we want to add in a picture. So we click on Add, and it's going to give us a mock-up. And usually you don't need to take everything. You can scroll to that and capture that and say Save. Now that when I add in another joint, eaves, you'll see that mine's been added. Now because I'm a MasterSeries employee, worker, whatever, I'm able to save into the MasterSeries database. You also have your user database, and then you can have all of them. So you will have a user database where you'll be saving to, and you can even kill the database. So replace the database, and you go and you find your master data file, and you find that, and you then save it to your other computer, or you copy it to the other computer and then bring it across. Now I am going to suspect that it will be in C drive, and it won't be in the it'll be in program data, I bet. Never done this. It'll be fun. There we go. and that's your template database. So you just take a copy of that over to the other machine and it should see it and work with it. I'm going to cancel that. So there you go, that's how we can save our connections. Now, haven't finished, because what we can now do very quickly is we can take all of these, including this one that doesn't actually work, and we can export them to DXF or straight to DWG format. And okay, page setup, all of those, and then we can say page layout, and we can say let's put the drawing up to 1 in 15, and there they come, and I'm going to say yeah, export and load. And hopefully it will load. We've just got all the text from all the files, but as we do anything, that will update itself. Just move to the next one and back again, and it won't be anywhere near as trashy. So here we come, AutoCAD's coming in, and that should give us a drawing with all of our connections, and I moved that one out of the way, and we can just play around with those as we want. Now, because it's a DWG, we have some more facilities, as in we can move handles and change values and whatever. So in this case, we probably shouldn't have gone out at that scale for that type of joint. 1 in 5 or 1 in 10 might have been better, but that's experience. For the eaves and apex type joints, that's not really a problem. There's plenty of room around here, and everything is on layers. Okay, so I'm going to close that down and just look through some of the questions for you guys before I let you get on. Somebody's just saying the clicking on the wells is a very useful tool. Well, you can click on any of the dimensions. Anywhere you have a dimension, you can click on it. Anywhere you have a member property, you can click on it. You can even, click on the, if you're accurate, click on the base plate and get the base plate thickness. There you go, or the end plate. First of all, if you take the eaves, one of the problems with the channels is that they're going to be unsymmetrically loaded, and that's not really covered in how the green books work. But from a splice point of view, it's one of the ones that people have asked for in the past. Is quite easy to work through in that. We'll just go for an ordinary splice. Instead of using a column section or a beam section, you want to change to using a built-up section. And your built-up section, because there is no PFCs in there, so your built-up section is going to be totally built up, and you could say, right, it's going to be whatever it is, 230 deep, and the flange you're going to make twice, and then you're going to put twice the load on it, so that one set of bolts does one set of shear, another set of bolts does the shear that doesn't exist. And that's how I would go about it at the minute. So if it's 75, I'd put 150 in. You could argue that it's 150 less an additional web, so let's put it in at 140. So you're going to have this half is going to be your channel, and then this half you'll just ignore. So that's how I would go about it for channels at the moment. It's one of the ones that I have on our list. We do get people requesting things from time to time, and we do listen. So yes, it's something we can look at. Right, what we can do is if you go to the simple connections, you have the angle, the fin plates. Fin plate column will allow you to do this section to be a hollow section, and then do the wall checks on that. So rather than having flanges on a web, if I was to come and say no, it is a square hollow section that is maybe not 700 by 700, but is something like 250 by 250, then you'll be able to look at that and hopefully make it work. But in this case, the supporting member is having a problem with tear out, and if we see, it's the wall dimensions against the stiffener, so the D over T ratio is incorrect and would need to be fixed. But we can do those, and we can do the full base plate hollow sections as you saw earlier. The other hollow section that we can do very, very well is the hollow splice, and I'll just take one of these to emphasize. So we can do a hollow section type apex splice, what I would call a pipe flange connection, and we can have plate above and below with bolts, or just to the sides, or just to the top. We can input the forces. In fact, in this one we can even put in the torsion, because it is dealing with torsional resistance and things like that. So that will also do quite good in connection design. Are strut buckling effects considered in the design of bracing joints? Yes. Somebody asked about moving the graphics around. At the moment, if you want to move your graphics, you have these little buttons here, so you can move those in and out. What you also have to remember is there's something called split screen. We can either use a left and right or a vertical split screen, and depending on your screen resolution, which will suit you. So it's worthwhile considering. And of course, that's then remembered when you go, and if you're printing out to the printer, you can also just drag that down, take as big a real estate as you want to get it as accurate as possible. For the single brace connection into the column web, does it check the column web? It'll check tear out of the column web, absolutely. Okay, ladies and gentlemen, I think that about covers it. We have run over the time, as exciting as it always is. What I'd like to do is to say that if you want to try the MasterSeries, if you want to try the connection design software, I highly recommend that you come in to products and then down to steel connections, and you can then start your free trial from here or from here. That sets up the switches that you need to get just the connections. If you want to look at, and it's better, the output, you can see a lovely sort of PDF brochure of all the different styles that we can do. You can also download sample PDF outputs. So if I look at output to the Eurocode, you will see a simple output for detailed followed by simplified, because we can reduce that output down in 3 different stages to only give us that's still detailed. Of course it'll be longer, it's going to take up the most. So here we come. I think this is it. Yep, this is the summary where you've got the graphic and just the summary results, all the unity values for each design. And then at the very end, if you really want to, you could print out just the graphics. There we go, coming out just the graphics to your printer, your PDF writer. Obviously you can also send them out to DXF or other. Somebody's again asking about bolt welded rather than bolted. The eaves and the beam under, beam over connections can all be done to bolted or welded. So yes, we do have some. So try the software, give me a shout, or Andras a shout, if you want some guidance on using the software. It's important not just to try software and run with it on your own, but to actually get into it as quick as possible through a little bit of guided learning. We will certainly facilitate that and love to do it. If you want to email us, I'm Tommy at MasterSeries.com, and Andras is Andras at MasterSeries.com. So if unsure, just do a little help at MasterSeries or sales at MasterSeries. You'll find us somewhere on the website as well. If you come in and say I want to connect, you can say I want to contact us about something. Everything's there. So everybody, I'd like to thank you all for coming along. I'd like to thank you all for giving me your precious time. I wish you a good and productive rest of today, and hopefully the weekend will be coming here soon and we can all relax. So I know that I've had people from all around the world, and we will get this video rendered up and recorded and edited maybe a wee bit as well and sent out as soon as we can. Everybody who has turned up today will get a link to download the video when it's available. Guys, ladies, gentlemen, everybody, thank you and goodbye.